Okay, picture this. You're looking at a world in our solar system that, from a distance, looks exactly like Earth. But instead of water, its oceans are literally filled with liquid natural gas. Welcome to today's explainer, where we're heading to Saturn's massive moon, Titan. We're going to uncover a biological gold mine that completely shatters everything we thought we knew about the search for alien life. If you're fascinated by the cosmos and all the weird things hiding out in the dark, you are in the exact right place. We are about to completely deconstruct our traditional understanding of biology. We'll break down the raw data to see exactly why scientists think this bizarre, freezing moon might just hold the ultimate key to extraterrestrial life. Let's dive in. So imagine you've just touched down on this alien world. You're actually standing on the shore of a massive lake, and its shimmering surface stretches way beyond the horizon, just catching the dim light of a distant sun. You can feel this gritty sand beneath your boots, gentle waves lapping at your ankles, and if you look up, you'd see rain falling from a thick, dense atmosphere. An atmosphere, by the way, that's actually 50% heavier and denser than the air we breathe right here on Earth. There are sprawling rivers, complex streams, deep estuaries, winding deltas, the whole shebang. From afar, it looks remarkably like a beautiful, kind of ghostly twin of our own planet. But that gritty sand under your feet? It's not made of rock or quartz or silica like our beaches. Nope. It's actually made of deeply frozen, rock-hard water ice crystals that have been shaved down by alien winds over thousands of years.
But here is the massive twist. That rain falling from the sky and those sprawling rivers carving up the landscape, they are not made of water. They're actually made of liquid methane and ethane. As one planetary scientist brilliantly put it, the surface of Titan is like if every gas station on Earth started leaking all over the place. I mean, wow. This is an entire world that is absolutely drenched in highly flammable hydrocarbons. It's an environment that's so incredibly alien, yet structurally so familiar, that it completely forces us to rethink what a functioning planet can actually look like.
What's truly wild here is how Titan perfectly mimics Earth's hydrologic cycle, just using a totally different set of chemicals. Think about it. On Earth, the sun heats our liquid water, it evaporates into the sky to form clouds, and eventually it rains back down to fill our oceans and lakes, right? Well, on Titan, that exact same cycle is happening right now, but it's evaporating and raining highly flammable natural gas. This makes Titan incredibly special. Aside from Earth, it is literally the only known world in our entire solar system that has stable, flowing liquids sitting right there on its surface.
Now you might naturally be wondering, how on Earth, or well, how on Titan, is methane sitting in liquid lakes? I mean, we literally use methane as a gas to heat our homes and cook our food. Well, the reason it's a fluid on Titan's surface is because the temperature is just unimaginably brutal. It sits at a staggering 290 degrees Fahrenheit below zero. That's about minus 179 degrees Celsius. To put that into perspective for you, that is more than 100 degrees colder than the absolute lowest natural temperature ever recorded here on Earth. At those bone-chilling temperatures, methane actually condenses from a floating gas right into heavy, frigid liquids that can carve out these vast planetary canyons.
But, as you can probably guess, this extreme environment creates a massive biological blockade. You see, life as we know it comes with this built-in planetary bias. We heavily rely on liquid water to act as a solvent. Water is that magical substance that lets molecules mix, regulates our cellular temperature, and helps our cells maintain their flexible shape. But at 290 degrees below zero, water absolutely does not flow. It acts like solid rock. If you were to drop an Earth-based, water-filled biological cell onto the surface of Titan, the proteins and fatty materials would just instantly stop functioning. The cell would freeze completely solid, shatter like glass, and instantly die. So life as we know it is completely locked out of this environment.
And this brings us to a really fascinating question. If water is completely off the table as a biological solvent, could liquid methane step up and do the job? Could an entirely different, highly bizarre form of chemistry act as the foundation for life in these frozen methane oceans?
To answer that profound question, astronomers turn to the ALMA telescope array. That's this massive network of highly sensitive radio antennas located way high up in the Chilean desert. They used it to peer deep into Titan's dense, nitrogen and methane-rich atmosphere. And what they discovered was nothing short of incredible. When sunlight hits the upper layers of Titan's atmosphere, it essentially acts like a microscopic builder. The solar radiation forcefully breaks apart the atmospheric gases, the methane and the nitrogen, and reassembles them, almost like playing with chemical Lego blocks. These fractured pieces spontaneously recombine to make entirely new, highly complex molecules that slowly drift down toward the surface. So the crucial point here is that this atmospheric Lego building process creates a very specific, highly important molecule called vinyl cyanide. Now down here on Earth, we primarily use vinyl cyanide in industrial manufacturing to make plastics and synthetic fibers. But out in the ultra-deep freeze of Titan, this molecule has an absolute biological superpower. It can naturally build long, interconnected chains that form flexible, living cell membranes. Unlike those rigid, water-based cells that would just snap in the cold, these vinyl cyanide chains remain incredibly fluid and flexible. That means a cell membrane built out of this stuff could actually survive, function, and even thrive at 290 degrees below zero.
To really put this into perspective, the observational data shows there is an estimated 10 billion tons of this vinyl cyanide resting in just one of Titan's primary shimmering lakes, Ligeia Mare. 10 billion tons! That is an almost unfathomable, staggering amount of raw biological building material just sloshing around out there. Astrobiologists have jokingly pointed out that if you wanted to use that vinyl cyanide to construct hypothetical alien creatures, let's say giant extraterrestrial squids, you would have enough raw material in a single lake to make billions of them. The sheer volume of prebiotic chemistry happening there is just mind-bending.
But you know what's crazy? Titan's alien surface lakes of methane and vinyl cyanide are only half the story. There is another massive secret hiding kilometers beneath that gritty sand and rock-hard ice crust. As we look past those freezing hydrocarbon rivers and dig down deep into the moon's interior, we find a completely different world entirely. Hidden in the pitch black, trapped beneath kilometers of ice, is a vast, global subsurface ocean of liquid water. Yeah, actual liquid water, much like we have right here on Earth. This immense underground ocean is kept warm by the friction of Titan's internal planetary heat. And to stop it from freezing completely solid in the frigid depths of the outer solar system, this water is naturally mixed with a heavy concentration of ammonia. The ammonia acts as a powerful natural antifreeze, keeping the subterranean waters fluid and moving. It creates a dark, churning ocean capable of supporting complex internal chemical reactions.
This duality is exactly why Titan is arguably the most exciting biological gold mine in our galaxy. It doesn't just offer one slim chance for biology, it gives us two completely distinct lottery tickets for finding life on a single world. On the surface, you have extreme cold, liquid methane solvents, and the potential for bizarre, vinyl cyanide-based life forms that breathe hydrogen. Meanwhile, deep underground, you have a warmer, pressurized water and ammonia ocean that could potentially host life much closer to the biology we understand here on Earth. That's two completely different evolutionary paths, all packed into one tiny moon orbiting Saturn.
And our ability to peel back these layers of Titan is constantly evolving. Back in 2005, humanity achieved a massive milestone when the Huygens probe safely parachuted through that thick haze and successfully touched down on the surface, sending back our very first images directly from the ground. Fast forward to May 2025, and the incredible James Webb Space Telescope is now peering through that same haze, tracking occasional methane and ethane showers in real time across Titan's northern hemisphere. The technology we use to analyze this alien world is only getting sharper, and with future missions on the horizon, we're inching closer and closer to actually sampling these environments directly.
Ultimately, Titan forces us to radically expand our bias of what life can actually be. Because think about it, if biology can utilize plastic-like molecules to build robust, living structures in sub-zero natural gas, what other impossible worlds out there in the cosmos are actually teeming with life? If we stop looking exclusively for Earth's exact twin, the universe might be a whole lot more crowded and a whole lot more bizarre than we ever imagined. Thanks for joining me on this explainer. Keep looking up and keep questioning what you know.